Okay, so what was your job? What were you supposed to do last night? You're supposed to do the additional review and find some questions. So, who found a question on the additional review? I found one, I think, on the regular review. I wanted to do that. I don't think we did yesterday. Let's get yours first. What do you want to do? Violet?
Can we do number 5 on the
Additional review number 5? Yep. So this is a big equation. The good news is that, what does that mean to me? That means I don't need to do, when I get my answers, I don't need to do plus 2 pi anything. All right, so I've got cosine squared plus 2 cosine plus 2 plus cosine. There is a serious issue with this, and that's right there. You cannot solve this equation with regular x's and 2 x's. So, luckily, we have memorized how to handle cosine 2x. What do you want to do with cosine 2x? Charlie?
Cosine 2x is another way of saying 2 cosine squared x.
Exactly. So that's one of our identities. Now, it looks like a quadratic equation, kind of all messed up. So I'm going to move everything over that way. So I'm going to subtract this over. That's going to be cosine squared. I'm going to subtract this over, and it's going to give me minus 2 cosine. And then I'm going to subtract that over, and it's going to give me minus 3. How does that look to everybody? Now, what do I need to do? Factor it. And it looks like, double check, looks like it's going to factor like that, which means cosine equals 3, not 90 equals, no, cosine not there, equals. Or cosine equals -1, and where does that happen? At bottom. So all that hideousness and one little answer just fine. Okay.
Can you do 11?
11 is another solve. This one is a calculator problem, only because, I think some of you get freaked out when it says calculator. The only reason it's a calculator is when I get down to this point, that's not going to be a number I know. Everything else is the same. So, add 19 and divide by 5. One of my personal problems is I don't do secants, so I'm going to rewrite this as cosine squared equals 5/23. Then I'll square root both sides. So cosine equals plus or minus the square root of 5/23. And that's why I need my calculator, because 5/23 is not on my unit circle. So, if the cosine is positive or negative, where will I be finding answers? Charlie?
Everywhere.
Everywhere. So it's like having your unit circle and having 4 dots on your unit circle. It's like saying I want all of the pi over 3 angles. Pi over 3, 2 pi over 3, 4 pi. I want all of the angles. Issue is, I don't know how big that angle is, so I'm going to have to go to my calculator, and I'm going to second cosine the square root of 5/23. So second cosine square root 5/23, and I got 1.086. So in quadrant 1, it is 1.086. What will it be in quadrant 2?
Pi minus.
Pi minus. So I'm gonna do pi minus 1.06. And then what's it gonna be, and figure out what that is, I'll be some decimal. And then what's this one down here in quadrant 3? Pi plus 1.06, I'll figure that out. And then quadrant 4, 2 pi minus 1.06. And those will be my answers. So Caitlin, I'm not taking the time to punch those in, but you'll punch those in. Notice that in the directions, what problem was this? 11? We had this. So again, those 4 numbers are the answers to the question I'm done. All right, who else? Avery?
Number 7.
7. Solve. This is kind of the same, but did you notice it is an inequality? Okay, so we're gonna start the same way. So I'm gonna move that sign over. And move everything over. And then it's another quadratic. So I'm gonna factor, hopefully. Right? Now, this is where it gets different. I mean, clearly this says sine equals 1/2. And this says sine equals -1. So these are gonna be key numbers for me, key values for me. But, since it's an inequality, this would be the answer, well, the angles would be the answer, if it were equals. But when it's an inequality, and I'm multiplying 2 things together, I have to remember what? That I can end up negative, this means negative, I can end up negative in 2 different ways. I can end up negative if this factor is positive and this one's negative. So in other words, sine is bigger than 1/2 and sine is less than -1. So this is positive, greater than 0. This is negative, less than 0. Because when I multiply a positive and a negative, I'm negative. Or it could be the other way around. This one could be negative, and this one could be positive. Right? This means negative. And the only way to multiply and get negative is if you have one of each. Okay. So where is the sign? All these are numbers on my unit circle. Where is the sign 1/2, positive 1/2? Pi over 6 and 5 pi over 6. Where is the sign -1? 3 pi over 2. Now, for case 1, this case right here, I want to be bigger, so here's your 1/2 line. I want to be bigger than 1/2, and I want to be less than -1. Are there any angles that are purple and blue? Nope. So no answers out of that case. So now I do the same thing but backwards. So I'm still gonna have purple dots at pi over 6 and 5 pi over 6. But this time I am shading below. And then I still have a blue dot at 3 pi over 2. But this time that be the whole circle? So this time I do have an answer. Be careful. Would you agree that your answer basically is everything that's purple? But remember, we're answering like this, so we gotta start at 0. So I'm gonna start at 0 and go to pi over 6. Everybody okay with that? And then I'm gonna start at 5 pi over 6 and go to the rest of the way around. So even though it looks like all one piece, we have to split our answer because we gotta start at 0. Okay, what if this had been a greater than? Then they would both be positive or both be negative, right? Yeah. Okay, who else?
Can we do, 12?
12 through so we need to show that cotangent plus tangent is secant times cosecant. Okay, what's cotangent? Well, it's 1 over tangent. Looking at this over here, I think it might be better to think about cotangent the way. It is 1 over tangent. No question, it's 1 over tangent. What else is it? Cosine over sine. And then tangent is sine over cosine. Now, I've got 2 fractions. And I'm adding them. What do I do when I have 2 fractions and I have to add them? I get a common denominator. My common denominator is going to be sine cosine, right? So this one needs a cosine. This one needs a sine in order to have the common denominator. Right? Now, there's my common denominator. Cosine squared plus sine squared. What's that? 1. So now I have 1 over sine cosine, which I can split into 1 over sine times 1 over cosine, and split that fraction, since I'm multiplying, and of course that's cosecant times secant. Okay. All right, who else found something new? Which one? 14. So we've got to find, we did something like this yesterday. We've got this polar coordinate, 3 comma 7 pi over 5. And we need to make equivalent points that plot in the same place. But we got rules to follow. So we want a positive 3 in A. We want a positive 3, but we need our angle to be negative. So thinking about where 7 pi over 5 is, which is down here, this is 7 pi over 5. What would be the coterminal negative angle? Negative 3 pi over 5, because 10 pi over 5 is the whole revolution. In the second one, we want to keep our positive. We want theta to be positive, but another positive, not the given one. So what would be a positive coterminal angle for 7 pi over 5? 17 pi over 5. What are we doing here? How do we get this one? We subtracted 2 pi. How do we get this one? We added 2 pi. That's how you find coterminal angles. back to the original. When we change the sign on R, what happens to our angle? It changes by 1 pi. So wouldn't that be, I was gonna say 2 pi over 5, but look at the directions. I want them both negative. So what is the negative version of 2 pi over 5? Negative 8 pi over 5. Very, very good. Take your time, think about it. Okay, and then for D, this is C, D. This could be D, right? This one I crossed off, that could be D because it says I want R negative and beta positive, so that would be an option.
Can we do 13 then?
13. I'm looking at a problem that is tangent squared over secant plus 1, and I'm ending up with cosines. Would you agree that secants and cosines are very strongly linked? Yes, they're reciprocal to each other. So the odd guy here is that tangent squared. What do I know, look at your denominator, what do I know about tangent squared? 1 plus tangent squared is secant squared. So what is tangent squared? Secant squared minus 1. And why am I kind of happy to see secant squared minus 1?
Because that is secant x plus 1 is secant.
Exactly, it's the difference of squares. Secant plus 1, secant minus 1. Which is gonna cancel my denominator. Okay, so now this is what I got. What's secant? 1 over cosine. So I have 1 over cosine minus 1. That's what I have left right there. Subtracting fractions. What do I need to do when I subtract fractions? Common denominator. Common denominator cosine. What's in the top? 1 minus cosine. Charlie?
I thought you couldn't like divide by cosine, because it's 0, right? Is that? Okay.
When I'm solving an equation,
Okay, it's different.
absolutely, you can't. Anytime you have a tangent or a secant or a cosecant or a cotangent, there are gonna be times it's gonna be undefined.
Oh.
That all automatically. So when you solve an equation, you can't do that. But in terms of verifying, I need to end up with a cosine in the denominator, so at some point I'm gonna have to divide by cosine. Right? Good question. Good question. All right, who else? Found something on this page. Well, I circled a couple that no one asked about, and maybe we don't need to talk about them. But what about number 3? Find all the asymptotes of this. We know that cotangent, we know that cotangent has asymptotes. And we know under normal circumstances, just regular cotangent, where are those asymptotes? In a normal cotangent. 0 and pi. And then 2 pi and 3 pi and so on. Those would be where they would be. So, this guy has been turned upside down, multiplied by 3. Neither one of those has anything to do with the asymptotes, would you agree? But this does. what does that do to this? Stretches it, times it by 3. So in the beginning, we said that our asymptotes were located basically at pi, pi n. Does that make sense to you, that the asymptotes are every pi? Think about that for a minute, pi k, whatever letter you're using. So this says I have an asymptote at 1 pi, 2 pi, 0 pi, negative 1 pi. Are you okay with that? But you said, what were we doing? Multiplying everything by 3. So now, these were the originals. So now our asymptotes are at 3 pi n. So in other words, my first asymptote will be at 3 pi, and then I have one at 6 pi and 9 pi and the other way too.
What would 0 be the first asymptote?
N could be 0.
Oh,
It doesn't. If you wanted, I started out writing that and then thought that was dumb, I don't want to need it, but yeah,
you could write it that way.
you could write it that way. All right, another one I noticed, or wanted to just talk about maybe, was number 8. Number 8 was sine 17 pi over 12. Is 17 pi over 12 on our unit circle? We got pi over 4, pi over 6, pi over 4, pi over 3, and so on. These are on our unit circle. So we got 2 12s, 3 12s, 4 12s. We can also come over here and do 5 6, 3 4s, which would be 8 12s, 9 12s, and 10 12s. So I got all these options just in the first 2 quadrants. I need to find 2 of them. You can go farther if you want. I need to find 2 of them that will add or subtract to this. So what do you think? 3 pi over 12 and 8 pi over.
Oh, 9 pi to 12, 8 pi to 12. Oh, it's just
Okay, so which what do you want now?
9 pi.
These 2?
Yeah.
Okay, 8 pi over 12 and 9 pi over 12. So basically, we are adding 2 pi over 3 and 3 pi over 4. There are other options. Wouldn't have to be these 2, but those 2 are okay. Everybody okay with that? So now we have a formula for this. Alright? We have a formula for this. Our formula says sine of the first, cosine of the second, plus cosine of the first, sine of the second. Now we go to our unit circle, these are all there. 2 pi over 3. Cosine is negative 1/2 and sine is root 3 over 2. 3 pi over 4, they're both root 2 over 2, but cosine is negative. Negative root 6 over 4, minus root 2 over 4. Multiplying these together, multiplying those together. So we end up with negative root 6. yesterday, the one we looked at yesterday, I don't think we did, so on the front side, I don't think we did number 3. We talked about it, I think, in terms of other problems, but I don't know that we did this one. If we did, I apologize. So what is this thing? What shape is that? Rose? We're graphing it, it's a rose. How long are those petals? 8. There's only 3 of them, right? They go out 8. We want to know what points are the farthest from the pole. Now, basically then, don't you want to know where the leaves are? Because isn't that when they're going to be farthest from the pole? Right? So we want to know where these are going to be, these values are going to be 8. When is R 8? Won't R be 8? Everybody agrees 8's as big as it gets, right? That's how long they are. Won't R be 8 when that is 1? When is the cosine 1? At 0. Is there any other times? Okay, so this angle, 3 theta, has to be 0. Is there, which means theta has to be 0. So there is going to be a leaf at 0. Agreed? Now there are other times cosine is 1. When else is cosine 1? 2 pi. So this could be 2 pi, which means theta is 2 pi over 3. There are other times cosine is 1. 4 pi, and lots of times, right? I want to remind you, you can go through all that if you want, but once you know where the first leaf is, you already know there's 3, and they're evenly spaced. So how far apart do the leaves have to be? 2 pi over 3? So if the first one's at 0, doesn't it make sense that the next one's at 2 pi over 3? And the next one will be at 4 pi over 3? And then if you kept going, the next one would be at 6 pi over 3? And so on. Okay, so what angles? This is the point 8 comma 0. This is the point 8 comma 2 pi over 3, 8 comma 4 pi over 3. Okay, all right. All right, anything else? That's all I got. I want to give you a couple more things. We still have 10 minutes, so we can answer whatever you want. I have 2 more possible review things for you. This one, and these are optional. These are optional. I'm just giving it to you because I have them. And so this first one I'm handing out, this is just about polar coordinates, finding the ones that are the same, which we practice a couple of times now. So finding polar coordinates that are the same. And one, which is a Unit 3 review, and it's kind of like a puzzly thing. Don't worry about that part. It just has review problems. It has good review problems on it. If you choose to do them, fine. If not, that's fine, whatever. I'm going to give you access to some more problems. I do want to remind you guys though, and I've talked about this a lot because it's the way I approach a lot of these problems. Now, this one, because the curve is so easy, I mean, we recognize that's rows, 3 leaves, okay? But remember, you can always think of the problem in its rectangular form. If it's easier for you to graph it in its rectangular form, so this is a cosine with an amplitude of 8. Right? Normal period of a cosine is 2 pi, but this one would be 2 pi over 3. If I went all the way around, I just erased my equation, but if I went all the way around, I'd have another one that ended at 4 pi over 3, and another one that ended at 2 pi. Would you agree with that? Right? So the question says, where am I furthest, or no, what was it? Yeah, furthest from the pool. So look at these answers. Is that what we came up with when we did it? So on the, so with this would be pi over 3. But that would have a negative R value, so that would correspond to 4 pi over 3. Because pi over 3, negative 8 pi over 3 is positive 8 pi over 3. So this so, yes, you're exactly right. All right, any last minute thing you can think about? Last time we took a quiz, I don't think some of us weren't as prepared as we needed to be. So let's prepare this time. Also, want to tell you that if you are interested, I have taken, remember the code, what was it, break the code or find the code, whatever that, they cracked the code. We went through all those 4 sets of problems, true or false. I have cut and pasted exact ones of those. So if you want to take a quiz, it'll count if you take it. You don't have to take it, it's optional. But if you need another grade, if you want a potentially good grade, I promise, I cut and pasted. I didn't change anything. So if you want to go through your cracked code or through those problems, I've just chosen some, not the whole sheet. But that'll be an optional quiz that you can take next week, okay? If you want to. It's optional. You have to do it during office hours or after school, completely optional, but I promise I cut and pasted them. So if you can do them on the sheet like we did in class, then you should be okay.
If you get like a really bad grade, does it not?
It counts.
Oh.
It counts. The quiz counts. If you're gonna come in and take it, and I'm gonna grade it, it's gonna count. So, if you can work through your practice code and do them, then you'll be fine. If you can't, then I wouldn't take the quiz. So next week, that's an option for you. Also, you see the growing piles of stuff over here behind Mr. Braun? These are our practice materials. Tomorrow after the quiz, I'm going to give you your first practice exam, and it will be due, a certain part of it will be due in our next class. So you have the weekend to get started reviewing. I'm going to give you last year's actual exam free response. We're going to work on that over the weekend. Okay? On exam day, you get a half hour for the calc, half hour for the no calc. So I'm going to give you both of them, and this will, one hour, spend an hour on it, see what you can do. That's tomorrow. Okay, what was your question? The back, simplify. Formula, Caitlin, sin x, cosine pi over 2, minus sin pi over 2, cosine x. It's exactly the same as this formula, except it's a minus. Now, cosine Sign pi over 2 is 0. So this is 1. Sine pi over 2 is 1. So I have a negative 6. That's my answer. That's just the formula. We're going to 4 next.
Is there an answer? Do you like
If there is, it's on campus already.
She had no idea what we were talking about. I just feel
Well, you and your new unit circle, because some of us still don't know it well enough. This is stuff we have to know, there's some practice for what we have to know. And this is last year's previously. So I'm not giving you an answer sheet. I got an answer sheet for one of the tests.